Hey guys, welcome back to our channel Logic to Code. So in this video I'll be talking about LRU Cache. So in this problem we have to give the definition of this get and put method, right? And this should work in O of one time, right? So if you don't know much about LRU Cache, then you can read about it, but in short it's a hardware or software component which is placed between CPU and RAM, right? And whichever the data that is most frequently used by the CPU, that is placed inside this cache so that the access time would be faster, right? But there is some capacity constraint of this cache, so we cannot put a lot of data in this. So once we hit the capacity constraint, so we need to evict some data point from this cache, right? And the strategy is least recently used, so whichever data point is least recently used, that would be evicted, and in place of that we'll be having some space to keep this new data point, right? So in this test case, if you see that the capacity of this LRU cache is 2, so first we'll be having 1 1. So in this case we'll be having a key value pair as our data point, so we'll be placing 1 1. Then after that we will be having 2 2. So once we get 1 1, which means this becomes now the most recently used, right? So after that we push 3 3. So as we hit the capacity constraint, so we need to evict some data point, and which data point we need to evict? That is the least recently used. And which is the least recently used out of these two? So 2 2, right? Because we just have access to 1, right? So after that we'll just get 2, right? Because 2 is not there, so we'll return -1, right? After that we'll just put 4 4. So it will evict key 1 1, right? Because we have 1 1 3 3 and 1 1 was the least recently used, so 1 1 will be evicted, right? So after that we'll just access 1 3 4. So 1 is not there as key in this cache, so it'll return -1. Similarly 3 will give 3 and 4 will give 4, right? So this is the key and this is the value, right? So we'll be using a doubly linked list to keep this key value pair. So we'll be having a pair of doubly linked list, so we'll be storing like this: key value, key value, key value, right? So this is the snapshot of our doubly linked list, and whatever is the most recently used key value pair, so we'll be bringing in the front of this doubly linked list, and whichever would be the least recently used, we will be having that key value pair at the end of this doubly linked list, right? So once we hit the capacity constraint, we know that the data point which should be evicted is from the end, right? So we'll just pop back from this doubly linked list, and we know that we have made a space for the new key value pair, right? So let me start writing the code, and in between I'll be explaining the remaining things, right? So one more thing, that we need O of 1 implementation of get. So for that I'll be using a unordered map, and that will be essentially having a relation between key and the iterator of this key value pair linked list, right? So let me show with that. First of all that we'll be making a doubly linked list to store our key value pair, right? So this is our doubly linked list. So let me make a variable capacity and also a variable c, which will essentially so here I'll be just initializing cap, so right, and now put method, right? So let me just write the put method first, right? So let's say if there is some key value pair which is already in this DLL, right? So what I'm saying is that, so for that let me just make a map also. So I'll be using an unordered map. So here the key will be the key of this data point, key value, and the value will be the map iterator of this list. right? So here the, let's say this is our DLL. So in this map I am storing the key as the same key and value as the pointer to this node key value, pointer to this node key value, pointer to this node key value, right? So let me write is unordered map right? So what I'm saying is that here, let's say if we wanted to insert this key value pair, so let me just check. So what is the rule of this unordered map here? So unordered map will keep track that whether a key value pair is there in this doubly linked list or not, right? So we'll just find here find key. If this key value pair is there in the doubly linked list, which means now this key value pair will become the most recently used. So we don't have to do anything, right? So let's say this key value pair is there but in the doubly linked list, but I want to now update this to 4. So which means that we just have to update the value of this key, right? So 2 3 becomes now 2 4, right? So in that case what we'll do is that, so first I'll have to erase this from this doubly linked list. After that we also have to erase this from another map, right? So for that what I'll do is that, so we'll erase this key first from this doubly linked list. So how we'll do that? So li.erase list.erase and this key, right? So this way I'll be erasing this older 2 3 from this doubly linked list. Now I also had to delete from this unordered map, and we'll do that by just removing this key, right? So now I have to insert this key value pair in this doubly linked list. So how we'll do that? So we'll just li.push front, right, make pair this new key value, right? So now I have just inserted this key value pair in this doubly linked list. So after that we just have to update in the map, so that if I have to access this key value pair in this get method, I'll be able to do from the unordered map, right? So how do I update in the map? So I'll just, so in the map the key of map is the same key, so umf key equals to li.begin, right? So the value is the pointer to the key value pairs, and I just know that I have just inserted in the front, so the pointer to this key value pair would be li.begin, right? So what would be the next case in this insertion? So let's say, so earlier it was if the key value pair is already in that, but let's say if now the capacity C is greater than cap, right? So if we hit the capacity constraint, it means that we need to remove something from this doubly linked list to insert the new key value pair, right? So how we are going to do that? So if we hit the capacity constraint, so what we'll do is that we have to just remove the last key value from this doubly linked list. So we'll just pop back this. So for pop back this, first we need to remove this from map, right? Because this key value pair, this key is also there in the map, right? So what I'll do is that I'll just make a pair temp, and in which I'll just have the last key value pair, right? So after that what I'll do is that I'll just erase it from our map, right? So what would be here? So that would be temp dot first, right? Because this temp dot first would be the key of that, and for removing this from the unordered map we'll be using key, right? So here it would be of key, right? Because for removing item from a list we need to give the pointer to this, right? And the pointer would be unordered map of key, right? and once we remove it from here map, we'll just remove from the DLL also. So for that we'll just do a pop back. Right now I'll make now essentially we have in space for this new key value pair, so I'll just push front make pair this key value pair, right, key value, and also we'll update this in our unordered map, right, same like here, right. So here we effectively what we did is that if you hit the capacity constraint, we remove it from the doubly linked list and also from the unordered map, and then we'll just update it in the front of this doubly linked list, right. And if this is not the case, which means we already have some space, so our cache is not full, so in that case what it will do is that we just do a push front. Because we know that there's space already, and we'll just update this in our map, right. And we'll just increment this C because we just have inserted one key value pair, so C is essentially used for tracking how many number of key value pair currently we have in our doubly linked list, right. So that's where I am using C here, right. So this is the definition of put method. Now let me show you how you can use this get method, right. So for that getting, we just will check that if of find key not equals to of n, which means we have this key value pair in our doubly linked list, and if it is not there, we'll just return -1 from here. But if it is there, how we are going to access that? So what we'll do is that we just have to find what is the value associated with this key. So for that I'll just use a temporary variable, and that would be effectively unordered map of key of second, right. So this will give the value associated with this key, right. So once we get the value associated with this, we need to remove, let's say if this key value is there in the mid, we just have to remove this from here, and we need to insert this into the front, right. So how are we going to do that? So first we need to remove this. So for that, so I'll just erase it from the list. So how we can erase it? So I'll be using this, right, and after that we'll erase it from the map, right. So I'll just erase it from map. Now I need to insert this key value pair in the front, right, because this key value pair becomes the most recently used, and the most recent key value pair is inserted in the front, right. So li dot push front make pair this key value pair, right, key, and the value that would be the same, and which is temp, right. So and we'll update it in our map also, right. So that would be li dot begin, and we'll return the value associated with this key, that is temp, right. So that's it. I think this code should work, so let me just run it. So it's giving some error. Okay, push front. So here it also will be push front. Okay, there is one more. So yes, it gets accepted on the custom test case, so let me just submit it. So yes, you can see here it gets accepted, right, So the code is pretty straightforward. So if you have any doubt, we just rewatch this video and you'll be able to understand, right? So I'm in sort using a doubly linked list, and whichever is the most recently used I'll be putting in the front, and which is the least recently used I'll be putting at the end, right? Key value at end. Based on that, I'm just updating key and inserting in this put method, right? So you just rewatch this video, you'll be able to understand this, right? So if you like our content, make sure to subscribe this channel. Thank you. Have a nice day.